Good morning, everybody. This is Mrs. Houtz, and today for your ABA this Wednesday, we are going to talk about section 4.5, which is called periodic trends. Okay, periodic trends just refers to repeating predictable patterns in the properties of the elements on the periodic table. So you learned a little bit about how Mendeleev organized the elements in the periodic table, and he did that based on atomic mass, but also on properties. So that was one of the really brilliant things that he did. So the periodic table is organized based on some of these patterns. Okay, and so today we're going to learn about two of these different patterns or trends. The first one's called atomic radius, and the second one's called ionization energy. All right, so let's start with atomic radius. That just refers to basically how big an atom is, and it's defined as the distance from the nucleus to wherever the outermost electrons are. So in this picture, this atom has 3 energy levels. So for this particular example, that distance out to the 3rd energy level from the nucleus would be the atomic radius. Okay, that'll obviously vary for different elements. Some elements have only 1 energy level, and then it would be this far. Some have 2, it would be this far, and so forth. So atomic radius just really refers to how big an atom is. All right, so let's think back for a second here about what you did yesterday when you learned about the attractive force between electrons in the outermost energy level and the protons. Okay, so if we think for a second here about the vertical columns on your periodic table, so things that are in the same group or family, from yesterday, one of the key points was that as you add energy levels, the attraction gets weaker between the nucleus and the outer electrons. So here was that picture from yesterday. Lithium had 2 energy levels, sodium has 3, potassium has 4. And as you can see, as we added more energy levels, this arrow got skinnier, which means there was a weaker force of attraction between these outermost electrons and the protons in the nucleus. Okay, the smaller atom, lithium here, I should say the one with 2 energy levels, has a very strong force between those electrons and the protons. Okay, so the question is then, how is that force difference going to impact the atomic radius? Okay, so in other words, what atom do you think is going to have a smaller atomic radius, lithium or potassium? Okay, and this has to do with the relative strength of the attractive force. Okay, so look back here if you need to and make a prediction about which of these things is going to have a smaller atomic radius, lithium or potassium. Okay, and then you can answer that question in the Schoology quiz.